Today we're going to work extra acid-base problems. These are weak acid and weak base problems. We're going to start with the weak acid problem. We don't know what the acid is, and it really doesn't matter because we can use the formula HA dissociates to H plus A minus. If we know what the acid is, great, we can use that. If we don't, it doesn't matter. We can always use HA. Okay, because it's a weak acid and we're looking for the equilibrium, we know that we're going to have an ICE table, initial, change, and equilibrium value. We're given the initial concentration, so we know we have this much of our weak acid. We must have it in molarity, so we pretend that nothing has dissociated at first. So initially it's 0.150 and 0. We're going to lose X, and gain X here. So our final equilibrium is 0.15 minus X, and X. So our Ka value will be H plus times A minus over HA, which we substitute in what we know. And here's the thing, if we do that, we have X times X divided by 0.15 minus X is equal to the Ka. Well, here's the problem. We have one equation and two unknowns. So we have to have been giving additional information in order to solve for one of the x's or one of the unknowns, so either the Ka or the X. We're looking for the Ka, so it has to be the X. Well, if we go back up here, we know that our pH is equal to 3.48. Now remember, the P function is equal to the negative log. So pH is equal to the negative log of the hydronium ion concentration. That being the case, we can calculate the hydronium ion concentration working the algebra 10 to the negative pH. Well, we know the pH, so if we take and go 10 to the negative 3.48 is equal to the hydronium ion concentration, and we run the math, we get the hydronium ion concentration is equal to 3.3113 times 10 to the minus fourth. That we know is the same as X. So we go ahead and plug it in. So we now know our Ka is equal to 3.3113 times 10 to the minus 4 squared. Now, down here we have to go, all right, wait a minute, we're going to subtract the X from the 0.15, and this should give us a value of 0.149669. Okay, so 0.149669, and we're going to run the numbers, and our Ka then comes out equal to 7.326 times 10 to the minus 7th. And because it's a K, it has no units. We have worked a weak acid equilibrium.